Hi everyone. Now I am going to discuss about the vernier calipers. This is my lecture number 6 from units measurement and dimensions. In this vernier calipers, I will explain you that what is the least count of vernier scale. Similarly, least count of the main scale. How to take the errors, positive zero error, negative zero error. Similarly, how to take the reading of vernier calipers, and also I will explain the few of the problems related to the vernier calipers asked in JEE mains as well as JEE advance. Now, before going to discuss that, first I will show you what is the this vernier calipers. Vernier calipers, we can see there are the left side, there are two jaws are there. So they are fixed. These are fixed. Right side is this is movable, and upper part also will move. This scale is this for this movable jaw. Vernier scale is connected. You can see 10th point is vernier scale. Main scale is there. You can see main scale reading 8th. It is showing main scale reading. We can see while moving this vernier scale, if you want to calculate depth of a pen or any depth by using this sixth point is there, no tail type is there, no that by using that we can calculate the depth. Okay, depth of any cylinder, depth of a pin cap we can calculate. So here also by using this second point is inside measuring faces. Actually, if you want to calculate inner diameter, you can calculate the we can use that that two inside measuring faces are there, no that. Now you can see outside measuring faces are there. If any object is kept here, length of an object, otherwise you can see a diameter of the cylinder, we can calculate by with the help of the lower jaws. These are the lower jaws we can see here. Now before showing this, I will actually show that other things also. Just you can see that. See, observe this. This is vernier calipers. Vernier calipers, you observe this. In this vernier calipers, if you see that there are, I have taken 10 divisions on vernier scale. We can check that there are 10 divisions on vernier scale, 0 to 10. If I want, I can increase that 10 to 15. I can increase to 20 also. You can see vernier calipers is having 20 divisions, 0, 2, 4, 5, up to 20 is there. You can see. If you want to, you can take the up to 10 divisions also. Okay. Now in this case, we can see how 10 divisions are there. These 10 divisions are coinciding with the 9 verniers, 9 divisions on the main scale. I will take one thing. Let us consider the whenever the lower jaws, whenever any vernier calipers is given, first you have to see that lower jaws are meeting each other. When lower jaws are meeting each other, if 0 on main scale is coinciding with the 0 of the vernier scale, we can say that there is no error in that. Okay. Suppose say if 0 of the if I will take the negative now. If you see here, just I made that error is -4, nothing but 0.04 centimeter reading is there. You just observe that in case of negative 0 error, sixth division is coincide. You just observe that 0.06 is there, no, in diagram. 0.06 here it is there, 0.06. Actually this 0.06 indicates that sixth division is coincide and 0 of the vernier scale is left to the 0 of the main scale. Sixth division is coincide, but error is, we can see that 0.0 minus 0.04 error is there. Observe this carefully. VSD coinciding is 0.06. Okay, error is value is equal to much here, minus 0.04 is the error. If you want to, you can see here whenever any object is kept, you have to add 0.04, we have to add, not 0.06. Be careful while doing the Vernier calipers. This one, if you want to, I will show you the one reading. Suppose say, if any object is kept like this between the lower jaws, we can see my 0 of the Vernier scale is right to the 1.5 on the main scale. 1.5 on the main scale is actually my main scale reading, and which reading is coinciding here, we can see in the diagram, fifth division is coinciding. That's why they are writing 1.5 plus 0.05. If you write that 1.5 and 0.05, you will get the 1.55, but adding digit is how much? Plus 0.04 centimeters. Here, why they are adding plus 0.04 centimeter? Reason is error is negative we got. Whenever negative error is there, which division is coinciding? If you want, you can see here again, which division is coinciding? Sixth division is coinciding. Negative error is there. While adding, we are taking like a, suppose if I take this one 5.55, earlier we have got now 5.55. In that case, we can see which division is coincide. Suppose any number I am taking randomly. See, plus 0.04 centimeter is added. Kindly keep in your mind, whenever error is negative, we have to take, like there are 10 divisions are there, we have to take the suppose say each division is 0. Some reading is giving like a 0.01 centimeter, we have to take the 0.04. Kindly keep in your mind. Suppose if I made that plus error, suppose a plus 4 is there error. Now you see, whenever two jaws are contact each other, now fourth division is coincide. Whenever fourth division is coincide, how do you know that it is a positive error? We can see whatever the 0 on the Vernier scale is there, that lies right to the 0 on the main scale. In this case, fourth division is coinciding, error is plus 0.04. If I want to calculate the any object, suppose say object is actually you can see that whenever object is kept, my Vernier scale 0 division is right side of the 1.5 centimeter on the main scale. So main scale reading is 1.5 centimeter, and sixth division is coinciding. So 1.5 plus 6, 0.06, if we add 1.56, we are getting 1.56, and we have to remove the that error is then a positive error, that we have to subtract. Corrected value will be 1.56 minus 0.04 centimeter. Observe this carefully. Whenever positive error is there, if fourth division is coinciding at the while measuring the whenever any object is not kept, no, when two lower jaws are meeting each other, if fourth division is coinciding and 0 on the Vernier scale is the right side of the 0 of the main scale, then we are writing writing like a finally corrected reading minus 0.04 centimeter. At the same time, if I take that minus 4, but we are not minus 4, suppose say if sixth division is coinciding, you see here, whenever the lower jaws are meeting each other, if the 0 on the Vernier scale is left to the 0 on the Vernier scale, which division is coinciding here? Sixth division is coinciding. You observe this carefully. Near the Vernier scale, it is showing that 0.06 centimeter. Okay, sixth division is coinciding, but while taking the any reading, you should not take 0.06, you should take like a minus 0. Say 0.04 you have to take. Understand that this is a major important point in a Vernier scale. Okay, I hope you got this point, and we are just moving to the our result. You just observe that this is a Vernier scale. No, I will write just what actually how to calculate. I am writing. Let us consider that this is the 0 on the main scale. This is a main scale. Main scale. Okay, I am taking one more point is a 0 on the Vernier scale. Down one is Vernier scale. If 0 on main scale is coincide with 0 on the Vernier scale, we can say no error. Okay. Now, next case, if this is 0 on main scale I am taking one more point here, 0 on Vernier scale. Vernier scale. Let us consider that whenever this is when all these things whatever I am writing is when no object is kept between lower jaws and lower jaws are contact each other. Lower jaws are contact each other. In that case, we are seeing error. Okay, what error is there? In this case, let us consider that 1, 2, 3, 4, 5, like this is there. I am taking like a, in this case, let us consider 1, 2, 3, 4, let us consider 5, this is 6th. 6th division is coincide. If 6th division is coincide, 7, 8, 9, similarly 10, something is there. You can see that whenever 6th division is coinciding, the error value whenever we are writing, this error is called negative error. Negative error. And if each division on Vernier scale is 0.01 centimeter is there, then negative error value is for 10 divisions we can write it as 0.10 centimeters minus 0.06 centimeters. That value is 0.04 centimeter. This is my negative error. Observe this carefully. In case of negative 0 error, we have to follow this. Whatever excess digits are there now, that will give the reading. Understand that? Not the 6 divisions are there, that will not give the any reading. This we have to keep in your mind while solving problems, especially for negative 0 error. So for negative 0 error, we can see that this whatever the 0 on the main scale is there, that is right side of the 0 on the Vernier scale. That's why now to get the corrected reading, this 0 is there now, this 0, we have to bring this 0, just I am writing one red color line I am writing. See, this 0 should be shifted like this. To shift that, we have to add, corrected reading will be positive. For corrected reading, we need to add plus 0.04 centimeter in the final answer. Okay, observe this carefully. Again I am telling what is the meaning of negative 0 error. Negative 0 error means if 0 on the Vernier scale is lies left to the 0 on the main scale, that error is negative 0 error. What is a positive 0 error? I am taking now positive 0 error. Let us consider 0 on the main scale. Whenever lower jaws are meeting each other, if 0 on, this is Vernier scale. If the 0 division on Vernier scale is coincide is right to the 0 on the main scale, we call that error is positive error. Let us consider there are some divisions are there. Here 1, 2, 3, 4, 5th division is coinciding. If each division is 1 VSD is, if one Vernier scale division is, we say that 0.01 centimeter is there, then positive error is plus 0.05 centimeters. For corrected reading in final answer, corrected reading in the final answer, we need to subtract it. We need to subtract 0.05 centimeters. Okay, that final answer is we have to subtract this. Kindly keep in your mind. Earlier we have to add, now we have to subtract. This is a positive zero error and a negative zero error. So nothing but to get the corrected reading, this value is there now. We have to shift to the left side. Okay, we have to shift like this in final result. That's where we are actually subtracting this. I hope it is clear for you what is the meaning of positive zero error, negative zero error. Okay, again I am telling what is the meaning of zero error. Zero error is in vernier calipers, two types are there. One is positive zero error, second one is negative zero error. Positive zero error means if when no object is kept and lower jaws are contact each other, if zero division on vernier scale lies right to the zero division on main scale, that error is positive zero error. Next, negative zero error. When lower jaws are contact each other, if zero division on vernier scale coincide with zero division on vernier scale lies left to the zero division on main scale, that error is negative error. Kindly keep in your mind, whenever negative error is there, to correct it, you have to bring the zero division to the shift to the right side, and to correct the positive zero error, zero division on vernier scale should be shifted towards the left side. That's why you are subtracting corrected reading for the positive zero error. For negative zero error, we are adding. And again I am telling, in case of negative zero error, if sixth division is coincide, if they given, I will give the different models. Sometimes without giving any diagram, orally or in question they will give that sixth division is coinciding. Nothing but you don't write directly if each division on vernier scale is equal to 0.01 centimeter. Don't write negative error is minus 0.06. It is not minus 0.06. I am writing it is not. Careful, be careful for negative zero error. It is not minus 0.06 centimeters. So kindly keep in your mind this. Most of the students they will do mistake here. The negative zero error is whichever remaining digits are there, no divisions are there, no, that you have to take. Here negative zero error value is not that. Negative zero error value is 0.04 centimeter is there, no, that is the value. Understand that? Only you have to keep in your mind only for the negative zero error. Positive zero error, as it is whichever division is coinciding, we can take that. Okay. Now I will explain you that some other points also you can see. First, suppose say whenever any scale is given to you. Okay, let us consider this is a main scale. Main scale 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 divisions are there in 1 centimeter. Okay, now you can say least count of main scale. Least count of main scale. You can write the least count of main scale as how many divisions are there? 10 divisions in 1 centimeter. So you can write 1 by 10 centimeter, that is equal to 0.1 centimeters, or you can write this as 1 millimeter also. Next, least count of vernier calipers. Let us consider this vernier scale. If it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If there are 10 divisions on vernier scale, how do you write the least count of this? I am writing now. On main scale, let us consider these zeros are 0, 1, this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the 10 on main scale. 10 on main scale. Okay, and let us consider that ninth division is there now. This ninth division I am writing like this. Okay, let us consider that 9 divisions on this vernier scale. Vernier scale. If 10 vernier scale divisions coincide with 9 main scale divisions, then we can write 10 vernier scale divisions is equal to 9 main scale divisions. Okay, now we can see 1 vernier scale division is equal to 9 by 10 main scale division, and each division on main scale is equal to how much? 1 millimeter. This is the 1 MSD value. 1 MSD is equal to 1 millimeter. So you can write 1 VSD is equal to 9 by 10, or you can write 0.9 MSD. I will write here 0.9 MSD, that is equal to 0.9 MSD, that is a 1 VSD value. If you want to calculate least count or vernier constant of vernier calipers, we can write least count is equal to 1 MSD minus 1 VSD. We can use this 1 MSD minus 1 VSD every time. Now you can see in this case least count is equal to 1 MSD is 1 millimeter minus 1 VSD is 0.9 into MSD. MSD value is equal to, you can write it as into millimeters. So finally you will get the 0.1 millimeter, that is also 0.01 centimeters. This is the least count of any vernier calipers. Not only this, sometimes they may give that if 20 vernier scale divisions coincide with 16 main scale divisions, then 1 vernier scale division is equal to how much? 16 divided by the 20 main scale division. Then we can write it as 4 by 5, that is 0.8 main scale divisions. That is 1 VSD value is this. If they give any main scale reading, we can write the 1 VSD minus 1 MSD minus 1 VSD is the least count. We will follow that result only every time. Next one, we can see 1 VSD is nothing but that whatever the each division on vernier scale. I am telling that 10 divisions are there. Each division how much distance is there, or what is the reading of the each division. That is a meaning. Okay, so least count is nothing but 1 MSD minus 1 VSD only you will use. Generally for solving problems, sometimes least count they will ask. That's why I'm telling least count formula. If any diagrams are given, then no need of all these things actually. Okay, suppose say in any problem if they give that if 11 vernier scale divisions are coincide with 10 main scale divisions. In that case we can write 1 vernier scale division can be written as 10 divided by the 11 main scale divisions. Observe this carefully. Okay, if 11 vernier scale divisions are coinciding with 10 main scale divisions, we write like this. If 10 main scale division, 10 vernier scale divisions are coincide with 11 main scale divisions, then you can write it as 1 vernier scale division is equal to, you can write it as 11 by 10 into main scale division. Okay, in this case we can get 1.1 times the MSD. So we can see each division on vernier scale is more than the division on the main scale. Okay, division on each division on vernier scale is more than the each division on the main scale. In this case, suppose say if 1 MSD value is equal to 1 millimeter is there. In that case 1 VSD also how much value will be there? 1.1 millimeter will be there. Observe this carefully, how to write these VSD values. Okay, in this case don't calculate the least count is 1 MSD minus 1 VSD. Don't write least count in this case not equal to 1 MSD minus 1 VSD. Reason is here it will be more than that. That's why you will not use this one. Understand that? In this case we will calculate like a 1 VSD value is there. No, by using that we can calculate the least value is there, that we will follow. Okay. uh, 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 According to the given diagram and given the whatever the given data is given now, based on that we can follow. Okay, next one we can see that in any vernier calipers, whenever it is given process to solve the problem, problems. First, identify one MSD. Identify one MSD value, means each division on main scale. Next, second point, identify number of divisions on vernier scale. Next point, find least count of vernier scale. By using formula, least count is equal to 1 MSD minus 1 VSD. Okay, next one, or we can write one more thing also. Each division divided by the number of vernier divisions. Okay, next one, each division measurement, actually that one 1 MSD also we can write that. Okay, 1 MSD. Next one, identify errors, positive or negative. Next one, error is nothing but we can write as least count into coincide division. It is positive error I am writing, coincide division. Negative error is nothing but least count into number of division reading is there, no, that reading. So you can write reading of number of divisions on vernier scale minus LC. I am writing not LC here, ending it, LC into coincide division. Okay, again I am giving here, if sixth division coincide, in case of negative error I am writing sixth division is coincide. Now error is negative error is equal to minus of 0.1 centimeter minus 0.06 centimeters. That value is minus 0.04 centimeters. Observe this. This is only in case of positive error. Next one, write the main scale reading when object is placed. Next, identify vernier coincidence VC, then vernier scale reading VSR, that is vernier coincidence into least count. So finally you can write main scale reading. I am writing MSR is a main scale reading. Now you can write it as corrected reading is corrected reading can be written as like R diameter of object, diameter of sphere, anything, okay, or length of an object, length of an object can be written as MSR plus vernier scale reading. If it is positive error, minus you have to write. If it is negative error, plus you have to write error. This is a final result for the any measured value by using vernier calipers. I am not telling least count is every time in terms of 0.01 centimeter only. As per the situation, as per the question, you have to follow. I hope it is clear for you. Now we are moving to do the problems related to the vernier calipers. I have taken already few questions. We can see very fastly. We can discuss now. In an experiment, the angles are required to measure using an instrument. 29 divisions on of the main scale exactly coincide with the 30 divisions of the vernier scale. If the smallest division of the main scale is of a degree, then least count of instrument is equal to how much? We can say according to question, 29 main scale divisions coincide with 30 vernier scale divisions. Okay, now we can write 1 vernier scale division is equal to 29 by 30 main scale division. They are asking what is the least count. Least count is 1 MSD minus 1 VSD. We can write 1 MSD is 1 MSD minus 1 VSD is 29 divided by the 30 main scale division. Finally, you can get the value is 1 by 30 main scale division. Just observe that 1 main scale division, smallest division of the main scale is 0.5 degrees. So you can write 1 by 30 into 0.5 degree. So this can be written as 1 by 60 degrees. Now if you see, there is no 1 by 60 degrees. 1 by 60 degrees also called 1 minute. So option is fourth option is correct option. Okay, like this data will be given, you have to follow. Okay, now next question. A spectrometer gives the following reading. So you can check that main scale reading is given. You can read by yourself question. Main scale reading is given. Vernier reading is given. Vernier scale reading is given. One division on main scale corresponding to 0.5 degree. Again they have given 30 vernier scale divisions coincide with 29 main scale divisions. One vernier scale division is 29 by 30 main scale division. It is also like earlier case only, least count you can write it as finally you can write 1 MSD minus 1 VSD. You will get 1 by 30 main scale division. But you observe that one main scale division is 0.5 degrees there. I am writing least count is 1 by 30 into 0.5 degree. That is equal to 1 by 60 degrees the least count. Now if you can see that say actually they are giving main scale reading as well as vernier scale reading also they have given. So I am writing main scale reading is given that 58.5 degrees and vernier scale reading is vernier coincident into least count. Vernier coincidence we can write it as 9 into least count is 1 by 60 degrees. If you see that 9 by 60, you can get the approximately value is how much? This is 3 times, this is 20 times. So 3 by 20 is there. You can get the approximately value is how much? 3 by 20 means 1.5 and 0.15 degrees you will get. Now reading, final reading can be written as main scale reading plus vernier scale reading. If you add both the things, you will get 58.5 degrees plus 0.15 degrees. You can get the value is 58.65 degrees. Second option is the correct option. Next question. The least count of the main scale of vernier calipers is 1 millimeter. So they have given least count of main scale, nothing but 1 MSD value is given 1 millimeter. That is equal to 0.1 centimeters. Answers they are asking in centimeter, that's why I have written. 10 divisions on main scale vernier scale coincide with the 9 divisions on the main scale. So you can write 10 VSD is equal to 9 MSD. We can write 1 VSD value is equal to 9 by 10 main scale divisions. That is 0.9 main scale division. Least count we can write 1 MSD minus 1 VSD. If I write the 1 VSD minus this, we can write it as 0.1 main scale division. Okay. Next one, when jaws are touching each other. Touching each other means actually we can see that zero error we are finding. 7th division of vernier scale is coincide the main scale, and 0 of the vernier scale is lying right side of the 0 of the main scale. Right side of the 0 of the main scale means positive error. What is the positive error value? I am writing positive error is plus 7th division is coinciding into least count. What is the 7 into least count value is how much? I am writing 0.1 into 0.1 centimeter. That is 0.01 centimeters. So you can add 0.01 centimeters. That is plus 0.07 centimeters. That is a positive error. Next, whenever object is kept, whenever see cylinder, the 0 of the vernier scale lies between 3.1 centimeter and 3.2 centimeters. Nothing but you see here. Somewhere you can see this is 3, this is 1, 3.1, this is 3.2. Now 0 on the vernier scale is like this, and which division is coinciding? 4th division is coinciding. Somewhere we can write the remaining values like this. Somewhere you can see 4th division is coinciding. This is vernier scale. We can see reading is this is 3.1 centimeters. That's why let the main scale reading is left to the 0 of the vernier scale you have to write. Okay, 3.1 centimeters. Next one, and vernier scale reading. We can write it as which division is coinciding? 4th division is coinciding. 4 into least count. So 4 into 0.01 centimeters. We can write the 0.04 centimeter. Now corrected reading. Corrected they are asking what is the length of the cylinder. Corrected length of the cylinder can be written as main scale reading, vernier scale reading. Error is positive, we can write the negative error. So this value is 3.10 plus 0.04 minus 0.07. Overall we can write it as 3.14 minus 0.07. So 3.07 centimeter is the required answer. You can see 3.07 is the answer. This process you observe that. Okay, how I proceeded. Next one. One main scale division of vernier calipers is a centimeter, and nth division of the vernier scale coincide with n minus 1th division of the main scale. See here, n vernier scale divisions coincide with n minus 1 main scale division. So 1 vernier scale division is equal to n minus 1 by n main scale division. Again, 1 main scale division can be written as a centimeter. A centimeter. They are asking millimeters, nothing but 10 a millimeters. In question options they are asking in millimeter. Okay, so you can write the least count value is equal to 1 main scale division minus 1 vernier scale division. So you can write it as 1 main scale division is 10 a millimeter minus n minus 1 divided by the n into 10 a. If you take the common 10 a, you will get the finally 1 divided by the n. So fourth option is correct option. Okay, next question. This is a 2021 question. The vernier scale used to measurement as a positive zero error of 0.2 millimeter. If while taking a measurement, it was noted that zero on the vernier scale is lies between 8.5 centimeter and 8.6 centimeter. I told already first reading is zero. Left to the zero of the vernier scale you have to see. I am writing again here. This is 8.5 centimeter. This is 8.6 centimeters. Zero the vernier scale is lies here. So our reading is what here? 8.5 centimeter is that you have to take. Main scale reading is 8.5 centimeter. Next, sixth division is coinciding. Sixth division is coinciding means what will write? Least count already they have written. Vernier scale reading is 0.06 centimeters. Next one, we can see positive error is this one. So positive error is plus 0.02 centimeters. We have to calculate the reading, corrected reading. Corrected reading, if you do that, we can write 8.50 plus 0.06 minus 0.02. We have to subtract that. If you subtract that, you will get 8.54 centimeters. First option is the correct option. Okay. Next one. If the diameter of the spherical bulb of measuring vernier calipers is 9, vernier scale are equal to the 10 divisions of the vernier scale. Same thing they are asking, 10 vernier scale divisions is equal to 9 main scale divisions. So 1 vernier scale division is equal to 0.9 main scale division, that we will follow. And each division and main scale is 1 millimeter is given. So we can write 0.09 centimeters. That also I have directly written. Okay. Next one, you need to calculate the least count. Least count is 1 MSD minus 1 VSD also you can write. 1 VSD is actually 1 millimeter is 0.1 centimeters. I am writing 0.1 centimeter minus 0.09 centimeter. We will get the 0.01 centimeter is the least count. I got the least count value. We can see the main scale reading is 10 millimeter is given. 10 millimeter is how many thing? 10 millimeter we can write it as 10 millimeter is 1 centimeter. 10 millimeter is 1 centimeter. Eighth division is coincide. So I can write it as main scale reading is 1 centimeter. Vernier scale reading is 8 into 0.01. That is you can write 0.08 centimeters. Now as a positive zero error they have given. So I can write it as a positive error is we can write it as plus 0.04 centimeters. Now diameter I am writing. Why? Because we will measure the diameter. Diameter can be written as 1 centimeter, that is 1.00, 0.08 minus 0.04. If you write this 1.04 centimeter is the answer, diameter. But they are asking radius of the bulb is how much. Most of the students they will do mistake like here. 1.04 centimeter means 104 into 10 to the power of minus 4 we can write. That is in meters. Okay. Now if you see that they are asking centimeters only they are asking, you write centimeters only. Centimeters we can write it as 104 into 10 power minus 2 centimeter is the diameter. Most of the students will write 104, but actually they are not asking the diameter, they are asking radius. Okay, radius is equal to how much? 104 divided by the 2 into 10 power minus 2 centimeters, that is equal to 52 into 10 to the power of minus 2 centimeters. Our answer should be 52 for this question. Observe this carefully. Okay. Next one, one division on the main scale, same thing like 1 millimeter, 10 divisions of vernier scale coincide with the 9 main scale divisions. When lower jaws are touching each other, vernier scale, 0 on the vernier scale lies to the right of the 0 of the main scale. This is positive 0 error. Positive 0 error. And which division is coinciding? Fourth division is coinciding. From above data, LC is equal to, you can write as 0.01 centimeters. We can calculate like earlier cases only. And positive error is, we can write it as plus 0.04 centimeters. And we can see main scale reading is 4.1 centimeters. Sixth division is coinciding. So from this, vernier scale reading is equal to 0.06, and the corrected reading can be written as, corrected reading is, we can write it as 4.10 plus 0.06 minus 0.04. If you calculate, you will get the finally 412 into 10 to the power of minus 2 centimeters. Answer is 412. Okay, observe this carefully. Next one. Vernier calipers 10 divisions coincide with the 9 vernier scale divisions. Here also we can write it as same thing. And each division, one main scale is given that 1 millimeter. So least count value again you will get like a 0.1 millimeter. That is also equal to the 0.01 centimeters. Least count I have written. But you observe question carefully. See, when both the jaws of vernier calipers touch each other, the 0 of the vernier scale shifted to the left of the 0 of the main scale. This error is negative error. Left side is there now, that is negative error. Which division is coinciding? Fourth division is coinciding. So our error should be equal to not the 0.04. What should be our value? Tell me now. Negative of. So total 10 divisions are there. For 10 divisions, what will be there? 10 into 0.01 centimeters minus 4 into 0.01 centimeter. We can get the negative of 0.1 minus 0.04 centimeters. So we can write minus 0.06 centimeters is our error. Kindly keep in your mind this error. Orally, if they give like this, like a question, if they give like this, without giving any diagram, we can calculate like this. If diagram is given, how to calculate, I will give. I have taken one of the JEE advanced question also, you can see. Now, whenever this object is kept here, 30 and 31 they have given, nothing but we can see that main scale reading is 30 millimeters, that is also equal to 3 centimeters. Next, sixth division is coincide, so we can write vernier scale reading is equal to 0.06 centimeters. Okay, now corrected reading. Corrected reading. We can write it as 3.00, next 0.06, next plus 0.06. Overall you will get 3.12 centimeters. This is error. Okay, error. Corrected reading, no, negative error is there, positive you have to write. Okay, overall you will get 3.12 centimeters. Actual answer should be this one. This is actual answer. Actual answer is this. Okay, this is actual answer. Kindly keep in your mind. But in JEE means exam, they have given there is no option for the 3.12, but nearest value you can take this. But that is not correct answer. Again I am telling, answer is 3.12 centimeter is the exact answer. If you observe in exam, closest value is 3.10. If you write like 0.04, if you write now, instead of minus 0.06, if you take minus 0.04, that time you will get the 3.10, which is absolutely wrong. Kindly keep in your mind. Starting of the diagram also I have shown like that animation. In that animation also reading, whenever sixth division is coinciding, we have to write error is minus 0.04. Whenever fourth division is coinciding, for the negative 0 error, we have to write the for the fourth division coincide, you have to write the minus 0.06. Okay, kindly keep in your mind. Next one, A traveling microscope is used to determine the refractive index of the glass slab. If 40 divisions are there in 1 centimeter on main scale, nothing but 1 main scale division is equal to 1 by 40 centimeters. Next, 50 vernier scale divisions coincide with 49 main scale divisions. We can write 1 vernier scale division is equal to 49 divided by the 50 main scale divisions. That's all. So you can write least count value is how much. Least count is 1 main scale division minus 1 vernier scale division. 1 main scale division is 1 main scale division only I will write minus 49 divided by the 50 main scale division. You can get the finally 1 by 50 main scale division. If you see answer they are asking in meters, so you can write the 1 by 50 into 1 by 40 into 10 to the power of minus 2. Overall, if you write this value as 1 by 2000 into 10 power minus 2, we can get the 1 by 2 into 10 to the power of minus 2 meters. These are the meters. I can write the value is 0.5 into 10 power minus 5 meters. That is also equal to 5 into 10 to the power of minus 6 meters. So our final answer should be what here? 5. Answer is 5. Next, I have taken JEE Advanced 2010 paper 2. Here they have given vernier calipers 1 millimeter mark on main scale. It has 20 equal divisions on vernier scale, which is matching with 19 main scale divisions. So 20 vernier scale divisions coincide with 16 main scale divisions. So 1 vernier scale division can be written as 16 by 20 main scale divisions, that is equal to 4 by 5 main scale divisions, that is also equal to 0.8 main scale divisions. So now least count value can be written as 1 MSD minus 1 VSD. We can get the 1 MSD value is 1 millimeter minus 0.8 millimeter. We can get the finally 0.2 millimeters. This should be the answer. See how easy question they have asked in 2010. Okay. Next one, in 2013, the diameter of the cylinder is measured using vernier calipers with no zero error. There is no zero error. It is found that zero of the vernier calipers lies between 5.10 centimeter and 5.15 centimeter. Now you can see main scale reading is equal to left side of the zero of the vernier scale is that you have to take 5.10 centimeters. Next, we can see 1 MSD value is equal to much. 1 MSD can be written as 5.15 centimeters minus 5.10 centimeters. Nothing but you can get 0.05 centimeter is the 1 MSD. This is a 1 MSD value. Now we can see this vernier scale is having 50 divisions equivalent to the 2.45 centimeter they have given. Nothing but 50 vernier scale divisions is equal to 2.45 centimeters. Now 1 vernier scale division is 2.45 divided by the 50 centimeters. If you write the value is 245 divided by the 5 into 10 to the power of minus 3 centimeters. So finally you can get the 1 VSD value is how much? 4 times 20 and 9 times. So you can write it as 49 into 10 to the power of minus 3 centimeters. This is the 1 vernier scale reading, 1 vernier scale division. Now you can see 24th division is coincide. Before that you have to write least count. 1 MSD minus 1 VSD. 1 MSD value is you can see 0.05 centimeters. This one is 0.049 centimeters. If you write this, you can get the value is 0.001 centimeters. This is my least count. I have written least count value. After getting least count, you have to calculate the vernier scale reading. Which division is coinciding? 24th division. 24 into least count. That is 0.024 centimeters. Now I have the least count value, sorry, vernier scale reading, main scale reading. You need to calculate diameter of the cylinder. Diameter of the cylinder can be written as main scale reading plus vernier scale reading. If you write the main scale reading is 5.10 plus 0.024, finally you will get the 5.124 centimeters. This is the reading. Okay, this is about the vernier scale reading. Observe this carefully. Next one. In 2016 paper 2 they have asked this question. There are two vernier calipers, both of which have the 1 centimeter divided into 10 equal divisions on main scale. Nothing but 1 MSD value is equal to 1 by 10 centimeters. That is equal to 0.1 centimeter. Okay, next. The vernier scale calipers C1 is 10 equal divisions on corresponding to 9 main scale divisions. I am writing now. In first case, you can see that in C1 calipers, 10 vernier scale divisions coincide with 9 main scale divisions they are telling. Nothing but 1 vernier scale division is 0.9 main scale division, that is equal to 0.09 centimeters. In C1, you just do the question properly. This one, they are asking what is the reading of this. Actually, you can see what is the reading they are asking. I will draw the diagram. You can see 2.5. This term is 2.8. Okay, this term I am writing here. This is 2.8. Okay, next, which division is coinciding here? 5, 6, 7. Seventh division is coinciding. I am writing only that 2.8 and this. See here. This is 2.8. 0 term is here. And you can see from 2.8 how many divisions are there? 1, 2, 3, 4, 5, 6, 7 divisions are there. Okay, now we write that up to 7 divisions. 1, 2, 3, 4, 5, 6, 7 divisions are there. Okay, from 7 divisions we can write it as 2.5 to these 7 divisions are there. Now you can write the value is equal to how much? 3. 1 minute, wait. These are the 7 divisions. These 7 divisions having 0.7 centimeters. Next, here how many divisions are there? Up to this 7 divisions are there here. 1, 2, 3, up to this 7 divisions are there on vernier scale. Now this is my reading. Actually, reading means what will write? Actual reading, tell me now. 2.8 plus x. Reading is 2.8 centimeters plus x. What is x value here? See here. You can say that x value is nothing but this 0.7 centimeters plus 7 divisions on vernier scale is there. No, each division gap, if you write that, 0.09 centimeter is there. Now for 7 divisions how much value will be there? 7 into 0.09 centimeters. Okay, 7 centimeters is equal to rate, is equal to plus x. Okay, now I am telling that above 0.7 centimeter is there. No, that is equal to this x reading plus 7 vernier scale divisions. I am adding this 0.70 centimeters is equal to 0.63 centimeters plus x. So x is equal to 0.07 centimeters will be there. Now we can write 2.8 centimeters plus 0.07 centimeters, that is equal to 2.87 centimeters. See, 2.87 wherever is there, here is there, and the second option also there. Why I am doing this one? No, diagram they have given. That's why no need to use any least count and all. Understand that? In second calipers, if we see that 10 equal divisions that corresponding to 11 main scale divisions. Okay, C2 I am writing now. C2, 10 vernier scale divisions is equal to 11 main scale divisions. Nothing but 1 vernier scale division is equal to 1.1 main scale division. And you know that 1 main scale division is equal to 0.1 centimeter. We can get the 0.11 centimeter is the 1 vernier scale division. You just go through this. Again 2.5, 2.8 is there here. 2.8 centimeters. 0 is here. Which division is coinciding? 5th, 6th, 7th division is coinciding. How many divisions are there on top? 1, 2, 3, 4, 5, 6, 7. This time 8 divisions are there on main scale. Now for C2 I am writing now. I will take one more paper. For C2 I am writing for C2. If you see that 2.8 centimeters, 0 division is here. This is my x. My reading is nothing but you can see this 2.8 plus this x value. That is my reading x value. Okay. Now you can see 1, 2, 3, 4, 5, 6, 7, 8 divisions are there. Up to this 7th division coincide. Know that. Now you can see the separation between each division value. We can see what is each division. I have written here 0.11 centimeters. Okay, 0.11 centimeter. Like this, how many divisions are there? 7 into 0.11 centimeter, that is equal to 0.77 centimeters plus this x is there. In this, how many main scale divisions are there? 8 divisions are there. For 8 divisions, distance is equal to 8 centimeters. Sorry, 0.8 centimeters. 8 divisions. Why? Because each division is 0.1. Each division is 0.1 centimeter. So I have written 0.8 centimeter. Now you can see that what is the reading of this? Reading is equal to 2.8 centimeter plus x. Now we are calculating this. 0.8 centimeter is equal to x plus 0.77 centimeters. So x is equal to 0.80 centimeters minus 0.77 centimeters. If you write that 0.03 centimeters, this is my x value. Substitute there 2.8 centimeters plus 0.03 centimeters. Finally, we will get the 2.83 centimeters. This is my reading of the calipers too. Okay, now you can see 2.83. I hope it is clear for you. Next one, in 2021, they have asked a question. One more questions are there. The smallest division on the main scale on vernier calipers is 0.1 centimeters. Means 1 MSD value they have given 0.1 centimeter. The division of the vernier scale corresponding to 10 divisions on vernier scale 10 VSD is equal to 9 MSD. So you can write 1 VSD value is equal to 0.9 MSD. Again you can write 0.09 centimeters. Why? Because 1 MSD is 0.1 centimeter. Now you can see in this, the figure below left shows the reading of these calipers when no gap between the two jaws. Now you observe that when no gap is there, already some reading is there. Actually, to get the original reading, you have to shift this 0 to the right side. Okay, that's where some reading is there. X. Which division is coinciding? 1, 2, 3, 4, 5, 6th division is coinciding. 6th division is coinciding. Now you see up to this how many divisions are there. Okay, how many divisions are there? I will draw the diagram here. This is my 0. This is actually 0 of the vernier scale, main scale, that is x. Now you can see how many divisions are there total. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. These 5 divisions are coinciding with some divisions. 1, 2, 3, 4, 5, finally sixth division is coinciding. Okay, now you see this gap is equal to how much? This gap is how much? 6 into 1 VSD, that is 6 into 0.09, we can write 0.54 centimeters. Fifth division is only coinciding now. Okay, like that you can 0.54 centimeters. But meanwhile you can see which division is there here. X plus 5 divisions are there now. 5 into 1 centimeter. Okay, now you can write it as error. We are going to write the error value. Okay, error is nothing but x only there. So you can write x plus 0.5 is equal to 50 is equal to 0.54. X is equal to, you can write 0.54 minus 0.50. So finally we will get x is equal to 0.04 centimeter. Error is negative. Error is negative. So you can write x is equal to minus 0.04 centimeters. I have written error value. Okay. Next one you can see that whenever object is kept. So you can see this is 3.1. Okay. Next which division is coinciding? 1, 2, 3. Sorry, first division only coinciding. If first division is coinciding, one division gap is equal to how much? 0.09 centimeters. But this division gap is how much? 0.1 centimeters. Now you can see what is my distance of x. So what is the distance gap? Tell me now here. We can write, I will write the down. For reading, x plus 0.09 is equal to 0.10. So we can write x is equal to 0.01 centimeters. Okay, this is my vernier scale reading. Vernier scale reading I have written. No list count, nothing. Okay, now we can see what is my main scale reading. So you can see 3.1 is my main scale reading. 3.10 centimeters. Reading, corrected reading I am writing 3.10 centimeters. Next plus 0.01. Next plus 0.04. Finally you can see 3.15 centimeters. Okay, here error is negative, I have added, that's why. So you can see 3.15 centimeter is the correct option. No list count, nothing I have applied here. You can observe this carefully. If diagrams are given like this clearly, no list count. One VSD is required, one MSD is required. Okay. Next one. During Searle's experiment, 0 of the vernier scale lies between 3.20 into 10 to the power of minus 2 meters to the 3.25 into 10 to the power of minus 2 meters of the main scale. 20th division of the vernier scale is exactly coincide with the one of the main scale. So now when the additional load 2 kg is applied to the wire, the 0 of the vernier scale still lies between 3.20 into 10 to the power of minus 2 and 3.25 into 10 to the power of minus 2 meters. But main scale of the main scale, but 45th division of the vernier scale is coinciding. See here, earlier 20th division is coinciding, now 45th division is coinciding. Nothing but whatever the extension is there in the wire, extension in wire is, let us consider x, that value is equal to 45 minus 20, that value is equal to 25 into least count you will write. What is least count value? They have given that is 25 into 1 into 10 to the power of minus 5 meters, that is x. Error in x, that is least count only, that is delta x, 1 into 10 to the power of 5 minus 5 meters. Maximum percentage error in Young's modulus they are asking. So Young's modulus generally what you write, f is equal to ya into here you write x divided by the L. So we can write it as y is equal to fl divided by the area into x you can write. So delta y divided by the y into 100 is equal to f is normal value, a is normal value. The only thing is what here, x. So we can write delta x divided by the x into 100. Delta x is 1 into 10 to the power of minus 5. 25 into 10 to the power of minus 5 into 100. 5 get cancelled. Finally, you will get the 4. All are absolute values only, except L is no error in no error. So M no error. Sorry, F is no error. F is equal to mg, no error. Only error is nx only. By using binary calipers, they have measured. Okay. One last question. A steel wire diameter is 0.5 millimeters. Young's modulus is 2 into 10 to the power of 11 Newton per meter square. Load mass is m. With the vernier of the wire with a load of 1.0 meter, vernier scale with 10 divisions is attached with the end of this wire. Next to the steel wire, wire is uh, a reference wire to which main scale of least count is 1 millimeter. So we can write it as 1 MSD is equal to 1 millimeter. Attached to 10 divisions on the vernier scale is coinciding with 9. So we can write it as 1 VSD. Obviously, we will get the 0.1 millimeter. Next, we can write it as 1 VSD. So we can write it as least count also. I can write least count is 1 MSD minus 1 VSD. Will write. Sorry, not 1 VSD. This one least count only I wrote here 0.1 millimeter. Next one. Initially 0 the vernier scale coincide with the 0 the main scale. If load of the steel wire is increases by 1.2 kg, vernier scale division which coincide with the main scale division is equal to how much? Now they are asking what is the extension in the wire. So we can write the F is equal to mg into x divided by the area. What is the area here? You can write the diameter is given. So you can see diameter is 0.5 into 10 power minus 3 meters. Radius is equal to 0.5 divided by the 2 into 10 to the power of minus 3 meters. So we can write it as 5 by 2 is 2.5 into 10 to the power of minus 4 meters. Otherwise 25 into 10 to the power of minus 5 meters. This is the radius. And now you can write pi into r square into length L. What is the length value? They have given 1 meters. Okay. Now other thing you can calculate like a extension in the wire is already you can see the least count is 1 millimeter is given. 10 divisions are given. You need to calculate the which division is coinciding. We have to calculate which division is coincide here. X value, right? F is equal to mg. M is, sorry, I wrote a little mistake here. Y is equal to this one. Earlier I have written y is equal to 1, no? Y is equal to FL by AX, no? Mg by X into pi r square into L. You calculate this value, you will get the certain number. How much number you will get? Suppose say generally you will get the 0.03 centimeters, like that you will get. Nothing but we can see that third division is coinciding. You can calculate that. Kindly calculate the value. Okay, answer is 3. Use the relation x value you need to calculate. Okay, I hope you have enjoyed this. I have given some of the questions. Maximum I tried to give the whatever questions they have asked in JEE Mains and JEE Advanced based on the vernier calipers. Okay, next lecture I will give the regarding the screw gauge. Okay, I hope you have enjoyed this. Thank you very much.